Alright guys, welcome to the final lesson of your linear unit. I'm hoping that everything up to this point has made sense and that you've been able to understand all the different aspects of linear and especially a lot of the algebra stuff and obviously a lot of the linear stuff which we'll be covering today. Last lesson, just a quick recap, we learned about graphing linear equations, so how to graph an equation. So if you've been given an equation, how do you graph that? Remember the two different ways of graphing your linear equations. You've got your gradient and y-intercept method, and the other method was your x and y-intercept method. Also, just remember about the special lines that we have when it comes to graphing equations. A y line looks like this, an x line looks like this. Your typical y equals mx plus c line will look something like this. Okay, so just if you need to watch that video again, please go ahead and do it before you watch this one. But this is the final lesson of our linear unit, and we're going to be focusing on finding the equations of a line. Okay, finding equations of a line. That's the main thing that we'll focus on. Right, so just a couple of things that we need to look over here before we start is that a horizontal lines. Okay, so horizontal meaning a line that looks like this. So just a straight flat line. Have an equation where y equals c, where c is the y-intercept. So what that's saying is basically, if you have a graph, so a good old Cartesian plane, and you have a line that goes sideways, horizontally, like so, like this, the equation will look something like this, just y equals whatever that y-intercept is. Okay, because there's no gradient. And you can see in the formula, there is no gradient. Remember, the gradient is the mx, or the m that is paired with the x. Okay, that's the gradient. Vertical lines, next thing here. Okay, your vertical lines have an equation where x equals k. Okay, k we haven't really seen, but don't worry too much about it. What that's saying is if you have a vertical line, which obviously goes like this. Okay, not that clear there, but let's draw a good old Cartesian here where we have an equation that looks like so. Remember the axis is, by the way, on any graph, any Cartesian. The horizontal line is the x, the vertical line is y, so this is x and this is y. Okay. Now this statement here is saying vertical lines have an equation of where x equals k. And what's that saying is the line that's drawn only intercepts the the x-axis. So if I was to draw a line here, okay, the formula of this line will just be x equals whatever the x-axis is. Okay, and the x-axis can be any line on this line here, or any number, sorry, on this line here. And any equation where it's x equals something, the line will look like this. Okay. Given the gradient m and the y-intercept c, use y equals mx plus c to state the equation. Now, I've spoken about this equation multiple times in my previous videos. Y equals mx plus c, okay, is the typical rule that we'll now use to represent any formula or any equation. So what that means is with this new topic, or this part that we're looking into, this is going to be the main rule that you're going to use, y equals mx plus c. And remember, in any formula or equation that looks like this, mx plus c, m represents the gradient, okay, and c represents the y-intercept. And just to tie this in with the previous things that you've done in your other lessons, the gradient is kind of similar to your common difference. So if you look back to if you remember back to our recursion unit, the common difference is the amount that the next term or the sequence will go up by. You'll notice that a lot of the stuff we do actually in maths is tied in with each other. Okay, very much related to one another. But in this case, just to recap that the m here represents the gradient, which is also related to your common difference. So how much does it go up or down by, depending on the x variable. So x variable is kind of like what term you're looking for. Okay. All right. Now the y-intercept, very similar. So again, to tie it back with the recursion unit, very similar to your initial value or starting term. Okay, value, also your starting term. So the x-intercept, remember, is where the line hits the y-intercept is where the line hits the y-axis. Okay, so if I drew a line here, for example, okay, and then my line could be like this. Okay, my y-intercept is right there. This line here. This is where the line, I guess you could say, starts. Okay, depending on what the context of the question is. But the y-intercept is where things sort of start, or where the line starts. You could say that. But again, that depends on the context. But understand that the C in your formula represents the y-intercept, and the m represents the gradient. And those are the two numbers that you're basically going to change when it comes to doing finding an equation of a line. So you just need to change m and c in your equation. Okay. Now, to find an equation of a line when given any 2 points, find the gradient, then substitute to find c in your formula here. Now, let me explain that really quickly. Basically, when you have a graph and you've been given 2 points, there's actually a way where you can find the formula here, which is y equals mx plus c. And the first thing you need to do is find the gradient. Okay, find the gradient. Okay, and then after you found the gradient, substitute any point into your formula. So after you've changed this gradient to whatever the gradient was, change x and change y into one of the points that was given to you prior to figure out what c is. Okay. Now, this part here is talking about this rule here, where y2 minus y1, x2 minus x1. Now, you probably have all seen this before at some point, y2, y1, x2, x1. And this is the rule that we're going to use to find the gradient. Okay, so remember m represents the gradient. And what this is basically when you've been given 2 points on a line, or 2 coordinates, 2 sets of coordinates in a line, you can use this formula to actually find the gradient. Okay, let's actually do that here. Some examples here. Here on this graph, I've been given a line, and there's 2 sets of coordinates there. Okay, the first set of coordinates that I have there, okay, are -4, -4, and then 0, 4. So this coordinate here, by the way, if you don't see it, this one here, this y-intercept. Remember, with any y-intercept, x is 0 and y is whatever the y-intercept is. So there's my formula there. Okay, so I've got 0, 4, and then -4, -4 as my 2 coordinates that I've been given. So now, how does that actually relate to the formula? Remember, the formula, okay, is y2 minus y1 over x2 minus x1. That's the formula that I'm going to use to find the gradient. Now, what you want to do is, when you've been given 2 coordinates, you want to understand which coordinate is which. So the first set of coordinates, you just want to name it x1 and y1. Actually, let's use colors here. So x1 and y1. Okay, and the second set of coordinates, you want to call them x2 and y2. Okay, so x1, y1, x2, y2. You've got 2 coordinates there. Now, you can see now in my formula, all you got to do is substitute these values into this formula. Okay, with y2, y1 over x2 minus x1. So let's do that. Let's rewrite my formula, where you've got y2. I'm going to use color to do this because I know people love color. Take away y1, okay, over x2, and take away what's the last one? Take away x1. Okay. Now just see what you need to do now. Change all the associated values with those numbers here. So this y2, you need to swap it with this y2 here. So when I write my formula, it should look like this now. -4, okay, take away y1, which is 4. Okay, which is 4 there. Take away 4. So that's the first part. Okay, second part on the bottom with the x's. x2, which is negative 4. So you're going to go negative 4. Take away x1, which is 0. So minus 0. So when you work this out, negative 4 minus negative 4 will equal negative 8. And negative 4 minus nothing leaves you with negative 4. So you're left with this, negative 4 over negative 8. And then when you simplify that, it's basically saying negative 8 divided by negative 4. You're left with positive 2. Okay, so that's saying that the gradient for this graph here, so m slash gradient, remember m represents gradient, equals 2 for this graph. And that makes sense because the graph is going upwards, therefore it must be a positive gradient. All right, let's go with another example here. I might not go through all of them, but let's go through, let's try E. Okay, let's try E. So here are my two coordinates for E. I've got 0, 2 for this y-intercept, and then I've got 2, negative 4. Okay, so let me write down my two coordinates there. Let's go to negative 4, and the other one was 0, 2. Now it actually doesn't matter which coordinate you use first, okay, when you do this formula of y2, y1, x2, x1. All that matters is you understand and you've labeled the correct ones, so you're actually using the appropriate coordinate when you use the formula. So in this case, I'll treat this set of numbers as my first coordinate, so x1, y1, this can be my x2, y2s. Okay, so remember my formula, y2, let's just write it here. So y2 minus y1 over x2 minus x1. Okay, so substitute your numbers into your formula. So y2 is 2. Take away y1, which is negative 4, over x2, which is 0. Take away 2, which is the x1 there. Okay, so working that out. Again, watch out for the negatives that are put together. A negative and a negative become a positive. So that becomes 2 plus 4 over 0 minus 2 gives you negative 2. All right, so that will be, right, get a space here. 2 plus 4 is 6 over negative 2. Simplifying that, 6 divided by negative 2 gives you negative 3. So therefore the gradient for this graph equals negative 3. Okay, and that makes sense because the line is going downwards. All right, just a couple things. Remember what I mentioned about this graph here? When a graph goes horizontal like that, okay, the rule for that would just be y equals 2. Okay, because it's just crossing through the y-axis, which is the y-intercept. And for a graph like this, the rule would just be x equals, well, if you look at where it hits the x-axis, it's negative 1. Okay, that's the rule for it. Just really quickly, maybe I might go through this one real quick as well, B. You can see that for this graph, okay, I've only got one coordinate and I haven't been given any other else, except in actual fact, I have been given another coordinate. It's right here. Okay, this coordinate here, right here is 0, 0. And it goes through the origin, which is the x and the y intercept right there in the middle, which is 0, 0. So I actually have two coordinates there to use now. So that means in my for my gradient, okay, I've got my 2 points, 0, 0, and then I've got 1, 3. Okay, so I might go, this can be my 1s, 1, x2, y2. Remember my formula, y2 minus y1, x2 minus x1. So this is going to be 3, take away y1, which is 0. 1, take away 0, which is that, which you are left with, I'll just go underneath, 3 over 1, therefore the gradient is equal to, when you simplify that, 3. Okay, and it's the same principle for this one here as well. All right, let's move on. So here you might have come across a question where you don't even have a graph, but you've just been given the coordinates. Okay, so let's do this. Really easy. Remember your formula. okay, of y2 minus y1, x2 minus x1, okay, and make sure that you understand which point is which. Okay, this is a good example to have because these are going to have negatives in it, right? So let's name them. This can be my x1s and y1. This is my x2 and my y2 coordinate. All right, let's substitute that into my formula. So y2 is -2, take away y1, which is 8, over x2, which is 5, take away x1, which is -3. Okay, so watch out for those negatives here. Okay, so I'll rewrite this so it's all proper. When you have two negatives, okay, it becomes a positive, like that. Okay, so you're left with, let's evaluate this. -2 minus 8 equals -10 over 8. Okay, evaluating that further, okay, gives you -5 over 4. And there's your gradient. M equals -5 over 4. You could simplify that into a decimal, 1.25, but I would prefer if you actually left it as a fraction for now. Okay, because most of your formulas, you might be asked to, for example, draw the graph, and it's easier to draw a graph if you do have your fraction, because you can just use it as a rise of a run for your gradient. Okay, all right, let's move on. So here's an example. Find the equation of the straight line below. So now, okay, we need to find the equation. So not just the gradient, but this is the full equation now. Remember, the full equation was y equals mx plus c. So the two things you're changing, oh, sorry guys, let's fix that. That's a horrible plus c. The two things you are changing in your formula is your m, which is the gradient, and the c, which is your y-intercept. Remember, this m, gradient, uses the formula y2 minus y1 over x2 minus x1. And the y-intercept is wherever the line hits the y-axis. Okay, so find the equation of the straight line below. All right, well, I'm going to write my equation again. Y equals blank x plus, actually, well, let's not leave it as plus because it could be a negative y-intercept, but I've got to change my gradient. So I have to find my gradient and I have to find my y-intercept. Okay, so let's start with the gradient first. Well, let's have a look at the graph. What are the 2 points that we have to help us find the gradient? We have 413, and what's this point here? Okay, well, that point is 0, 1. Okay, that coordinate right there. So I have my two coordinates now, 413, actually, yep, and 0, 1. And just to prove, by the way, that you don't actually, it doesn't matter which one you use as x1, y1, as long as you actually have and understood which one is which. Okay, I might use this as my x2, and this can be my y2. This can be my x1, this is my y1. Okay, you don't actually, all that matters is when you do this formula, that for that coordinate that you have, so for that specific coordinate, you've got to make sure that they're both x2, y2. You can't make this x1 and this one y2, for example. Or you can't have x2 and then y1 here. It's got to be x2, y2, x1, y1. Okay, for those specific coordinates. So just remember that. So when I do my formula, I'll remember y2 minus y1, x2 minus x1. All right, so substituting that, y2 is 13. Take away y1, which is 1. And then x2 is 4. Take away 0, which is x1. So what you're left with here is 13 minus 1 is 12. 4 minus 0 is 4. Simplifying that, the gradient is equal to 3. So that means in my formula, I have to start off with the gradient of 3. So y equals 3x. Okay, and then the next part is finding the y-intercept. Well, that's easy enough. It's already given to us right there. My y-intercept is +1 or +1. Remember, anything above the x-axis on the y line is a positive. Anything below will be a negative. So that means my y-intercept is a plus or a +1. There it is. y equals 3x plus 1. That's my rule. Easy. And that goes for any graph that you work with. Okay, let's do one more example here. Okay, where it's got slightly different coordinates, but more or less the same. Okay. So for this one, you've got your two coordinates. Again, remember, you need to figure out what your formula is. So y equals blank x, and then what is the y-intercept? So remember, that's the gradient. That's the y-intercept. Okay, so again, here, use your y2 minus y1 formula. Your two coordinates are 3, 7, and your other coordinate here, what's this one here? Well, what's that coordinate? It is the y-intercept, so it's 0, 1. So 0, 1. Okay, is your other coordinate. All right, so you've got x1, y1, x2, y2. Label it if you need to. Remember your formula, y2 minus y1, x2 minus x1. So that means y2 is 1, and y1 is 7. So 1 take away 7 over 0, which is x2, take away x1, which is the 3 there. So that means your answer is 1 minus 7 is negative 6. 0 minus 3 is negative 3, which means that therefore simplifying that will give you a gradient of 2. So your gradient is 2. And then your y-intercept, just looking at your graph, I can see that it's at positive 1, sorry. Right there, so your y-intercept is positive 1. And again, if your gradient, or sorry, if your y-intercept is down here, then that means the y-intercept must be a negative. Also, if your line is going the other way, then your gradient must be a negative. But if you did all this correctly, you will automatically get the negative gradient anyway. Okay, so just watch out for that. Okay, let's do these examples. Find the equation of the line shown. Now, this one's slightly different. Okay, guys, if you have a look, okay, you can see that the line does not extend all the way through the y-axis, which means that you can't actually see what the y-intercept is. Okay, and so that's where this part of the, so if you remember back to earlier in this lesson, that's where this part will come in handy, this second section here. Okay, where you find the gradient and then you substitute a point into the formula to find out what C is. So let's work that out. So first and foremost, remember that you're trying to find the equation for this, and the format of the equation always looks like this. So y equals something x, gradient x, and then what is the y-intercept? Okay, so in that case, this is your gradient, and this is your y-intercept. So that's what we're looking for in our formula. Okay, let's start first with our gradient. The gradient's always the easiest to find anyway. So your two coordinates there have been given to you, 3, 11, and then 6, 7. Okay, there's your two coordinates there. Again, it doesn't matter which one you call which, okay, but as long as you call this set x1, y1, or x2, y2, I might just switch it around. Let's go x2, y2, and I'll go x1, y1. Okay, just for the lols. Lol. Okay, so x2, oh, yeah, Toddy, I forgot the rule already. So the rule, remember, was y2 minus y1 over x2 minus x1. Okay, don't forget that rule. Very important for the gradient. All right, so let's work this out. Let's just change color. y2 minus y1. So it's going to be 11. Take away y1, which is 7. x2, which is 3. Take away x1, which is 6. Okay, we're going to have a funky number here, but that's okay. 11 take away 7 is 4. Okay, and then 3 take away 6 is negative 3. So that means my gradient, I can't simplify that any longer, but my gradient is negative 4 over 3. And that makes sense because if you look at the gradient here, okay, it's going, the line, sorry, look at the line, it's going downwards, which means that the gradient must be a negative line, or the common difference means it's going down. So negative 4 over 3, that's my gradient. All right, easy. So now the next part is we need to figure out what the y-intercept is. All right, this gets a little bit tricky, but bear with me because it's not as bad as you think it is. What you need to do is write the formula that you have so far. So y equals negative 4 over 3x, and then we'll just go plus c, because I don't know what c is. Now all you need to do to figure out C, because remember C is the y-intercept, is now just get one of the two coordinates that you've been given. Oh, you can look at it up here. One of the two coordinates that have been given and just substitute it into your formula to figure out what the y-intercept is. Okay, to figure out what the y-intercept is of that that line. So let's see. I might pick I don't know. Pick any points. I might just go with 6, 7. Easier numbers to work with. So if I use 6, 7, remember the point 6, 7. That's x and that's y. All I have to do is now substitute 6, 7 into this formula to figure out what C is. So if y was 7, and then you've got negative 4 over 3 times, and x, okay, was 6, okay, plus 6. Let's work this out. Okay, so 7 equals negative 4 over 3 times 6. That'll equal 24 over 3, negative 24 over 3 plus C. Working that out, 7 equals negative 24 over 3 is negative 8 plus C. Okay. Now, as you recall, Toro does like having his unknowns on the other side, so I might put this on the other side. But you don't have to do this. I just like doing it. Equals 7. I've basically just swapped them around. Doesn't change anything. Okay, just I like having my unknowns on the left. So now I want to try and isolate C. This is a minus 8, so when I put it here, it becomes a plus 8. Therefore, my y-intercept C is equal to 7 plus 8, which is 15. Therefore, in my formula, so the final formula that I have up here, my y-intercept is positive 15. There's my formula. Let me write the whole thing down so people can get it. Y equals negative 4 over 3x plus the 15, which was that y-intercept there that we found. Okay, so when you get to this point where, okay, you've got to find the equation for this line. You've only been given 2 points, but you can't see the y-intercept. First thing you do is find the gradient, which we've done. Okay, get the gradient, and then pick one of the points from that from the 2 points you've been given, and just swap it into the formula. And then from there, solve for C. Solve for the y-intercept, and then that's basically it. Let's do one more, and then we'll do a worded question. So here we've got two coordinates again, and we need to find the formula. So formula, remember, is y equals something x, and then something, which is the y-intercept. Okay, I'll write it again for you guys. So remember, that's the gradient. You don't have to write this if you don't want to, but for the people that, so you guys really understand it, that looks like gradient. Okay, so for you guys to understand, I'll just leave it there. So you've got your 2 points, 4, 7, and then 8, 2. Okay, remember to just label your points so you know which one you're working with. You don't have to do this if you actually get it, but again, for the people that need it, it's there. Okay, remember your formula, y2 minus y1, x2 minus x1. Okay, so that means y2 is 2, take away y1, which is 7, over x2, which is 8, take away x1, which is 4. Okay, so working that out, 2 minus 7 is negative 5, 8 minus 4 is just 4. So your gradient is negative 5 over 4. Alright, so your m gradient, negative 5 over 4. Okay, that's what you've got so far. So now we have to look for the y-intercept. So what you need to do here is write your formula so far. So you've got y equals negative 5 over 4x and then plus c. We'll just make it plus c for now because we don't actually know if it's a positive or a negative gradient, but leave it as plus c for now. Now what you do is when you get to this point, just pick one of your coordinates. I might pick 8, 2. Those are some nice numbers, so let's use 8, 2. Remember which one is x and y. Obviously that's x, that's y. Okay, so in your formula, you now need to swap, or you need to now substitute x and y into this x and y. Let's just change color for this. So x is going to be 2 equals negative 5 over 4 sorry, y is going to be 2, my bad. X is going to be 8, so times 8 plus the c. Okay, so let's solve this. Solve for c on this one. Okay, so 2 equals negative 5 over 4 by 8 is equal to 40, and negative 40 over 4 plus c. Okay, let's solve that. 2 equals negative 40 divided by 4 is equal to negative 10 plus c. Now, totally won't swap it around, but look, you can just do this as well. This is a minus 10. It becomes a plus 10 here. Or you could just write it up here if you wanted to, plus 10. Okay, so that means c, therefore must be, I'll just write 12 equals c, or c equals 12. Okay, same thing. So that means your y-intercept on your formula is 12. So the final formula is equal to negative 5 over 4x plus 12. Okay, I hope that's made sense.